Alright, let's now do some exercises together, shall we? I got two exercises over here for you. Both of them are more about rewriting the definition for the relational operator, rewriting into something that's equivalent. Of course, we don't just rewrite arbitrarily. That's not our intention. The first one, I would suggest if you already got your slides, try to skip this slide just for now. Look at the video, all right? I really want you to think about this exercise over here. The first exercise, I want you to define, remember what this operator is? It's relational image, right? So this will be the image of R over set S, right? I want you to define this relational image operation in terms of other relational operators or relational operations over here, all right? If you don't need any hints, pause the video now, all right? If you need some hints, let me give you a little bit hints over here. You may want to think about to rewrite the relational image in terms of some subtraction, restriction, or maybe some domain or range operator. Try to choose some of them from these four I just mentioned. Restriction, subtraction, and also domain and also range to see which one might fit. You will be able to rewrite this expression over here in terms of those I just mentioned. All right, that's my hints to you. And now please pause the video and do the exercise. Assuming that you thought about it and try, it's okay if you didn't really succeed, but at least you tried. This will be the answer, okay? If I say I want to calculate the relational image of R over S, it would be equivalent to calculating, first of all, the domain restriction of R over S, first of all, and that will be a relation, and then I just want to take the range, right? For those of you who can think abstractly, maybe having this equal sign over here, you already know what I really mean. But that's okay. Let's now try to make it more concrete by considering one example. Let's now talk about this and then try to apply the definition to convince you. Okay, let's now take a look. Of course, what we did earlier was to really apply the set comprehension definition for the relational image. You can definitely refer to it. It's actually from last week. But for now, let's now use this new definition. Okay, rather than using set comprehension, we are trying to define one operator in terms of others, assuming that we actually know very well what these two really mean, right? Let's now take a look. Okay, what we'll do is, so this is going to be equal to, right? By the way, so this particular set over here that we want to calculate the image over is the S over here, right? And according to the definition, it's going to be the range of some relation over here, right? And it's going to be S, which will be AB. Let me write it down. AB is going to be what we want to restrict the domain of R into. And so that'll be domain restriction and then R over here. Right? Hopefully so far so good. All I did was to apply the definition over here and replace S by this particular input for the relational image. Right? And let's now try to go further. And it will be the range of, and now let's now try to, since we've got the parentheses over here, so we got to order that, we got to evaluate that first. What will be the domain restriction of R into AB, right? That's something we did already, so I'm not going to bother you too much. Let me just tell you visually how to calculate that. So we got AB, AB, and that's it, right? So all we got is we're going to collect all these pairs over here, and we're going to get the domain restriction, which will be just another set of pairs, just another relation. It's going to be A1 and B2 and A4 and also B5 over here, right? Okay, so far so good. You can see all that remains are simply not with their first element being A or B. Okay, so we got this. And how do we calculate the range for this particular new relation? That would be, well, simply choose the second element, right, and collect them together. 1, 2, 4, 5. And that's what we'll get eventually. So that'll be 1, 2, 4, and 5 over here. And I'm pretty sure if you try to apply the set comprehension definition for this RS, in that case, you're also going to get exactly the same result. That's why we can say this will be the alternative definition meaning for the relational image, right? Hopefully you're okay with this exercise. So why are we doing this? We're just trying to understand more about how you can combine different relational operators together. For example, for those of you, let me just mention a side notes. For those of you who actually have already studied, or might be studying, or will study databases, okay, databases, and a very fundamental category of databases is called relational databases. And the relational databases, of course, the way to implement it is by using SQL queries, right? And do you know what the formal foundation for SQL query is? One of them is called relational algebra. And relational algebra is really about how you can manipulate relational operation like a range or subtraction, something like that. Not exactly the same, but similar idea. So for those of you who might have already studied databases, you can definitely refer to your relational algebra notes, and you might be able to draw some connection. Okay, I just want to point out to you, it's a side note. Okay. Not really relevant to this course, but whenever I think about anything that's relevant to other parts of your degree, I'll try to mention that. Good. So that's about the first exercise. Let's see the second one. And the second one is our new friend, which is the overriding, right? Notice that it's not domain subtraction, it's actually overriding. You can see the horizontal bar goes across the boundary for the triangle, right? R overridden by T, right? That's something we just did the exercise on, right? In the earlier slides. Can we try to rewrite this R overridden by T in terms of other relational operators? And this one, I will really encourage you to think a little bit harder about this. I think the ultimate answer that you're going to see will definitely give you more new insight about the overriding operator. And no hints. The hints will be, the way you solve it will be very similar to how you came up with the answer for the relational image, right? Think about all the relational operators that we have discussed so far, and then you will choose some of them and combine them together to define what it means for R overridden by T. All right, you can now pause the video and think about it. Assuming that you try it and hopefully you succeeded, let's now take a look. This will be the answer. All right. Not surprisingly, you can see we have a union over here corresponding to the disjunction in the set comprehension, right? Remember, actually, not surprisingly, if you can refer to the earlier notes. When we define the union set operator, the way we did it is by using the set comprehension notation, and inside we actually use a disjunction operator, either this or that. So this part over here is just about the T itself, right? We say that it's gonna be all the all the order pair that already exist in relation T, and then we want to say that for relation R, we want to keep some of them. What do we keep? We want to keep those that do not belong to the domain. We want to keep those order pairs whose first elements are not members of the domain of T, are not. So that's why we're doing domain subtraction. That's intuitively how you can understand this algebraic definition alternative. You can whenever you talk, you should really know both. You should know both the set comprehension definition in the earlier slides and also the algebraic definition over here in the current slides, right? Study this definition closely with my intuitive explanation, and let's now do one example together, right? Let's say we want to do this particular overriding, okay? This one here, okay? Let's now take a look. Right, so now we want to, the same relation that we want to consider, and then this is definition, okay? And by the way, in case you're wondering about how to write algebraic definition, so this is something called algebraic definition. Algebraic definition. And what you can think about algebraic property. That would be a more accurate saying. It's more about algebraic property for the relational operator, right? We're saying that by applying relational overriding, it would be equivalent to applying this, and this in this particular order, right? Algebraic property. And you know about algebraic property from your earlier math courses a lot. You do that all the time. For example, there is one property called commutativity. Okay. For example, you can say A plus B is equal to B plus A. Right. This is a very straightforward in the algebraic property over here. Right. Just anyway. So that's something we'll see maybe later for other operator as well. All right, let's now think about how we can calculate this using the definition over here, right? By definition, let's now write it down from scratch again. So R overridden by, right? You can see the horizontal bar should go across the boundary for the triangle. Another relation T is going to be A3 and also C4 over here. All right, that's our problem, okay? And it's by definition going to be equal to a union. So let me put a union over here. And it's going to be two parts. The first part will just be T. And T will just be this guy over here, right? This is T. So let's write it down. It's going to be A3 and also C4. Okay, that's the first part. What about the second part? The second part is going to be this expression over here. Let's write it down. It's going to be the domain of T. Let's be a little bit faster in calculation. What's the domain of T? Domain of T is A and C, right? Let's write it down directly. Domain of T is A and C. And then it's going to be used for domain subtraction of R. Over here, right? That's what we have. And what will be this part over here, right? So that means we're going to, for this part here, we're going to come up with another relation, except that all the order pairs that involve A and C as the first element, the domain value, they're going to be not collected in the resulting relation. More precisely, which pairs should we get rid of? Well, let's take a look. So you can see here we got A and C, A and C. A here, C here, A here, C here. Anything else, right? You can see all the other pairs that's left. The first element is neither A nor C, right? So these will be the ones to get rid of, right? And these one will be the ones to really collect, right? Just be careful whenever you calculate it, right? So let me just keep the paper a little bit cleaner, okay? And let's now try to write this down over here. So that'll be B2. Okay, it's going to be another relation here. So B2 and B5 pair. And also D1 and E2 and F3. Right, I'm pretty sure you know how to put the union of them together. Okay, I'll let you do it. And you can definitely see the slide for the complete answer. And the result overall is going to be a single relation, a single set of order pairs. And one more connection to make. You should not be very surprised. The ultimate result over here that we calculated, even the intermediate result, is very similar to what we just calculated earlier when we applied the set comprehension definition for the overriding. Over here you can see exactly this over here is just the same as this one over here. They are just the same, not surprisingly. Alright, so that's the second exercise. You can definitely also refer to the slides. The illustration over here, the annotation is exactly what I just demonstrated. Okay. Alright, so that's about the overriding and also some additional exercises for you to understand more closely about the relational operators. So up to this point, we have finished all the basic relational operators. And the next topic will be about functions, which is a special kind of relations.